Hi everyone, my name is Wycliffe from Kendo, a medical physicist by profession. I wish to welcome you into the newly formed channel called Physics Studio. In this studio, we'll be discussing how physics is applicable to the health science, and the program is going to span from radiology to radiotherapy. We are going to do applications of physics in real life situations. And as we are going to undertake our course, there are some few topics that we are going to have emphasis on, or some units that we are going to do a lot of emphasis. Now, we are going to do a lot of emphasis on radiology physics. We are going to do emphasis on applications of physics in real life situations. We'll also do emphasis at advanced stage into nuclear medicine. We'll also study computational neuroscience, and as well as invite or invoke the use of mechanics as well. Now, this studio welcome the students spanning from medicine students, radiography students, biophysics students, laboratory science students, and any other person who is curious enough to know how physics can be applied to enhance the healthcare. Now, today we are going to take a voyage into, we're going to dwell into our very first topic, our very first lecture, that is Radiology Lecture 1. And what we're going to study is the basic atomic structures. Now, as we know, an atom is composed of three main particles. And the particles that are known is, we have the protons, we have the neutrons, and then we have the electrons. Now, the protons and the neutrons are strongly bounded together by a strong force called gluon that we will discuss as down the course. Now, and the electrons are at the orbit around the neutrons. Now, as I have said, that atom is comprised of three subatomic particles, that is electrons, that is negatively charged, protons, that is chargeless, and neutrons, that is positively charged. And together, protons and neutrons forms the nucleus, while the electrons orbits around the nucleus. Now, the protons, now it forms the type of an element. The proton number really gives us the element number, and it also forms a vital part when it comes to nuclear reaction. But when we go to electrons, as it orbits around the nucleus, it forms a crucial role when it comes to the chemical properties of an atom. It is electron that gives us the valency and how reactive an element is going to act, particularly when undertaking a chemical reaction. And we have to understand the difference when talking about the chemical reaction, the nuclear reaction. Chemical reaction takes part in the outer shell of the atom, whereas the nuclear reaction takes part within the nucleus. Now, these elements, as was observed by the Rutherford and Bohr, we have said that the atoms is composed of three particles. The nucleus forms the protons, the neutrons, then the electrons orbit around. And this one is attributed to the great scientists, that is Rutherford and Bohr's model. Now, normally, these nuclides or these atoms are being noted or presented in a certain manner. Now, for instance, when you want to present an atom, normally it's done in terms of the proton number or the atomic number and the mass number. Now, when you look at this here, X is the element symbol or chemical symbol for the element. A forms the mass number, while Z will form the atomic number, but the atomic number is informed by the number of the proton number. Now we might take an example for carbon. And when taking an example for carbon, we look at carbon 12 in particular. Now carbon 12 is atomic number 6. It has 6 protons and 6 neutrons. When these neutrons are brought together, they give us the mass number. So that the mass number is a composition of the proton number and the neutron number, whereas the proton number informs the atomic number. We really need to get that one right. Now, as far as elements are concerned, these elements are normally grouped into nuclides, and actually there are more than 3,000 nuclides. Now, these nuclides, they are classified into 4 classes. The first class is an isotope. An isotope is an element with the same proton number but different in mass number. Now, the division in the mass number is informed by the fact that these elements are having the same proton number but they have difference in neutron number. As you can see, carbon 12 and carbon 13. Carbon 12 is having 6 protons and 6 neutrons. When they are brought together, they bring carbon 12. Whereas carbon 13 is having 6 protons and 7 neutrons. When they are brought together, they bring carbon 13. As we have said, that the mass number is informed by the number of neutrons and protons. So the isotopes, when asked to define an isotope is an element with the same atomic number but different mass number. And the mass number difference is informed by the fact that the mass number difference here of carbon 13 and carbon 12 is informed by the fact that carbon 13 is having 7 protons, whereas carbon 12 is having 6 protons. Now then we have isobars. Isobars are elements of the same mass number but different in proton number or atomic number. Now, in an event there is a difference in atomic number, that one means that there are 2 different elements. As you can see, we have 99 here and 99, but these elements are not the same. Molybdenum, titanium, different elements. Now we have the third class as isotons. Now isotons are elements, they are elements with the same neutron number but different proton number. These 2 elements here also are totally different elements. As much as they have the same proton number, there is deviation in the as much as they have the same neutron number, but there's deviation in the proton number. Therefore, it becomes a totally different element. And we can take an example, maybe carbon 14, that is having 8 protons and 8 neutrons and 6 protons. And nitrogen, that is having 7 protons and 7 neutrons. When you check their mass numbers, you realize that the mass number is different. They have a different mass number. Or you can take carbon 13 and nitrogen, where carbon 13 is having the same. They have the same proton number, but there's the difference in atomic number, and therefore they are different elements. So isotons, an example of isoton, clearly within the sphere of the 20 elements, we can talk about carbon 13 and nitrogen, because carbon 13 will be having mass number of 13 and proton number of 7. Then carbon 14, not really carbon 14, but nitrogen will be having a mass number of 14 and a proton number of 7 and a neutron number of 7. Then we have an isomers. Isomers here is an element that mirrors the other. In other words, it's the same element, but one exists in a metastable state and the other one is in a stable state. Now, that is all we have for today, for today's class. I thank you for taking your time to listen to the lecture. I welcome you to the next lecture that we are going to study the orbitals. Thank you very much and have a good day. See you in the next lecture.